In this video, we're going to do lots of examples involving transformations of functions. So we're not going to plot points specifically. We might catch a few points that we want to know how to move them around for the transformation. But one thing I want to be real clear on is that this, for example, y equals f of x over 2, that is not like your equation. What it's saying is that this is the transformation that is made to the input of this function over here, f of x. Okay, it's not saying sometimes people want to write them as like a linear equation, for instance, or like pick points and just plot them right into there, but that's not what we're doing. We're using this, we're saying, okay, this is a transformation of we're affecting the input by a half. So we have a horizontal stretch actually by 2. Okay, so that's the kind of thing that we're looking at. So we're going to take our original function. We'll actually plot it down here too so you can see what happens, and we'll see how it stretches when we consider by a factor of 2, which is what this like rule is saying. So I want to reference this sheet that I'm going to post in your assignment. I want to be clear here that we should have parentheses here and here. If we are having the input affected, we're going to look at horizontal. Okay, so that's our input. Then we also want to check out what's happening. So if we have a situation like ours, let me get a brighter color here. Okay, we have b times x. So ours is a fraction, right? So we're going to multiply each x coordinate by f of x by 1 over b, which when we do that, it's actually going to come out like this. So ours was a half x, right? So it's x over 2, which would be 1 over 1/2, because that's really like 1/2, right? So how that works out is we're really multiplying by 2. So we're stretching by a factor of 1 over b, which is its inverse, which is 2. So I just want to point that out, how this will match up on the table. So let's go back to the other document. So this is your examples. So I drew in this little graph. It's just the same exact thing. And now I'm just going to pick a few key points to multiply by 2. And I'm going to horizontally stretch. So let's do something that'll really stand out, like we'll use the bright pink. So if I have my x value originally is -1, my y is 0, so I'm not changing anything for the y. I'm just multiplying that -1 x value. So this was -1, 0. Okay. And I'm going to multiply it by 2. So that would now become, it transforms into -2, 0. So that goes here. My next point that I have, so this is kind of what it was in the blue one. Once you get used to it, it goes quicker. So we'll just do this one a little slowly. So we have -1, 0 transformed to -2, 0, because we're doing a horizontal stretch by a factor of 2. Okay, in other words, multiply all the x's by 2. So now this point down here, this one is negative 3, 2. The y is going to stay the same, but we're going to have a negative 6 for the x now, because we're going to multiply that negative 3 by 2. So now we're way over here. We're going to kind of have to go off the chart a little. And then last one over here, we have negative 5, 0, and that's going to be multiplied by 2 and just the x, and transform over to negative 10. So negative 6, 7, 8, 9, 10. So I'm just going to kind of judge right there. And then you can see how that's stretched horizontally. Okay. As opposed to vertically with the up down. Now this one on the right, part B, that's a little bit easier. We just have some shifting happening. So let's take a look at that. So shifts, you can either do your y or x first, but remember stretches and compressions as well as reflecting have to come before shifts. But this one's fine. So let's look at what we have happening with the x's. So we have a horizontal shift to the right by 2 units. Okay, so if we are here, there's our little graph. I usually just, put it in there for now to begin with. Oops, gotta get my points right. Get that one out of it. You don't have to do that. You can just kind of look up there as long as you transfer, okay? And then this point is going to shift right. This point is shift right too, because remember, we're not going to go to the left. This is actually our vertex form, so we want to make sure our vertex is in the right spot. So this is the first transformation. I'm just dealing with the horizontal. Okay, so that's the same exact shape, no stretching or compressing. I'm just picking it up, moving it over. So now for the next thing, we need to deal with the output. Okay, so that's going to be a vertical shift up. So definitely specify what you're doing by 4. So now now I'm looking from the pink one. I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. I'm just going up. All those dots go up 4. And I'm done. Okay. You can do that all together at the same time, but I just wanted to make sure you saw the stages. And when on a quiz or a test and I ask to see stages, I'm doing that because I don't want you just popping it into a some kind of app and getting an answer. So I want to see how you lay it out. You may use dash lines or something like that, or tell me, like writing this stuff in up here is really important. Usually I just ask you to do it verbally. I don't even always ask you to graph it, though you need to do that sometimes. But if you wanted to do it all together at once, you would need to do it more like this. You would say, okay, if I'm shifting right 2 and then up, then I put my point. This is a laser thing, so it'll disappear. So you can do that, but you should probably, tell me or show me for a quiz or a test, especially something I'm grading. On your homework, it's up to you. That's fine. And again, you're going to get lots of homework with this, so just pick about 75% of the as a whole and get a good spread of different kinds of problems so that you're prepared for quizzes and tests. So like I said, I used to not even grade these. It used to just be do it, but and be prepared. But I think then people aren't as motivated. They like to have a reward for doing it all. And then I get a chance to check in with you on it too. Okay, so we're taking this same little shape, and if we look here, we'll do pink for our first stage. We have a horizontal flip. So our x's are going to become negative, well, the opposite of what they are. So if they're already negative, then they're going to become positive. So let's do that first, and then I'll show you how we're going to stretch the output by a factor of 3. So when it's outside of the f of x, it's affecting the vertical. So that'll be our vertical. Okay, so first we have a horizontal flip, and that's going to be over the y-axis. If you forget that, just think about like, well, if I'm multiplying every x by -1, it's changing signs. So this will go over there. This one is going to reflect to be here because that's -3. Now it's +3. The y stays the same. The -5 becomes +5. So that's stage 1. Then I'm going to go ahead and do my vertical stuff, which is a stretch by a factor of 3. It's going to abbreviate by 3. So all my y's now, so this affects the y stuff, okay? The other one's the x stuff. So if I have a y of 1, I'm going to be keeping that x value the same, and I'm going to be multiplying the y, which is 0, by 3. So it just stays right there. Now this one, -2 is my y, and I'm going to multiply -2 is my y value. So I'll just say multiply y value -2 by the stretch factor. So it's going to be -6, but the x stays as is, right? We already took care of the x's. You can do it again all together once you get used to it. And then the 0 for the y times the stretch factor of 3 is just 3. And that is my answer for this transformation. Now on part D, it's saying add to the graph to create an odd function. So we're going to review that back to what odd means. Odd means it actually rotates 180 degrees. So it's kind of like you do a flip and then another flip. So let's take a look at that. Okay, so I just jotted down a couple of notes that we've learned from 1.5a. Odd, if AB is on the graph, then -a, -b is also on the graph. And we also have f of -a would become -f of a. So how we can deal with that is we can just say, okay, if I have -1, 0, then I know I have to have 1, 0 will also be on the graph. And then if I have -3, -2, then I also need to have 3, 2 on the graph. And we want to leave this blue piece here. It's not changing. We're just adding to make this thing even, so they have to kind of go together, right? And then the last one, if I have -5, 0, that means I need 5, 0. So this is my addition to make it even. So my whole answer are those together, not just one thing like before that we were looking at. So that's just the first page of this. We do have a lot more to go through. So I'm going to separate out the graphs. And the next page, though, 68, actually, how about we do this one as, you can start it on your own and see how you do for classwork. But just be careful of your open circles. Right, so I'm going to leave that one for classwork, and then I'll put in the answers for you. And if you're stuck on that, in your comments when you go to turn things in, or just email me even before you turn it in, and you can ask me more questions about it. I'll draw everything out and then I'll go through it verbally using the laser pointer. But you can skip that part if you got them all right. All right, so let me pause that, write them out, and you can check your answers, and then this will be the end of part 1 of the transformations. Okay, so your final answer for part A should be this purple one right here. So what we're doing is flipping over the the x-axis, multiplying every y by -1. So I did that here. Sometimes it might help you to just write out the points either, on the original. I usually like to even put the original over, but once you get used to it, you can just have the points there. Some people put them in a table. I could have also at the same time divided every x by half, but I want to show you the stages. So here's my flip over the x-axis this time, and then I have to shrink up every x value by half. So I have 3 now becomes 1.5, so on and so forth. Okay, so you can see how that works. 2, and it becomes 1, 5, 2.5, and then 6. Just make sure you keep that open circle, and you're putting that at, or actually it was at 7 was the original, so it's going to be at 3.5. So I hope you're getting the idea with this. Okay, so for B, just going through real quick, I've done it out so you can see how you match up for your classwork. So we have vertical compression by 1/2. That means all your Y's are going to be compressed down. You're going to cut them in half. So that's why it looks kind of squishy there. And then you take that whole thing and shift it left 3 units on all these dots. And your final answer is in the purple there. So I am circling and trying to give you the stages so you can know. I'll also number them just in case it's hard for you to see colors. So and whoops, that's original there. And then our final one is in the purple, so that's the last. Okay, so I hope you're getting the idea. Again, just do the rest of these for classwork. This one I may just kind of go through. Actually, I'll go through these two on a separate video just because they're kind of puzzly. Okay, so here's our classwork answer for y equals g of -x equals, -1. Remember, these are the transformations that are being performed. It's not saying that's like a linear function for you to graph. I shouldn't see just a straight line. I should see this original shape moved around on the graph. So we have the first stage here is a horizontal flip, so all the x's become their opposite, and then we just simply shift down so we get that shape right there. And D and E, I'm going to just make a separate video. I should probably have done that earlier.